The webinar will begin shortly. Please remain on the line.
Ну, что, жду, она что-то, блин, шорт ли говорит. Можно секундочку зайти? Я просто не пойму, что она говорит. О.
The webinar will begin shortly. Please remain on the line.
Remain underlined. Да, можешь подойти на секундочку? Да, и он походу говорит, я ничего не слышу.
The webinar will begin shortly. Please remain on the line. Welcome to the webinar. Please stand by. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Okay, can everybody hear me now? I was getting a lot of messages that people were unable to hear me. Awesome. Okay, so my apologies for the mess up on the audio. It's very easy here to, with many levels of mute buttons here, to not have some full audio. So thank you very much for pointing that out to me. Welcome to the webinar. So I'm glad that you've all been able to make it. My name is Spencer Snowling from Hydromantis, and I'm glad you all made it and were patient while I sorted out my audio issues. And so this is going to be the first of 3 webinars that we are going to do. And they're going to cover all of the new material and new elements of things that are going to be in the new version of GPSX version 8, which will be coming your way shortly. So, as I mentioned, my name is Spencer Snowling. I'm VP of Product Development here at Hydromantis. this. And as most of you know, I spent a lot of time working on the development of GPSX. It's partly the thing that I've done most of my career. And I'm very excited when new versions of the software come out. We've been very anxious to be able to hold this webinar and to be able to tell you about all of the new and fascinating things that are coming in the software. In fact, there's so much of it that we had to break it into 3 separate webinars here. So I'm glad that you've been able to join us. Okay, so as usual, what will happen today is that I'll talk a little bit about how we upgrade the software for the new version 8 when it comes to you. Then we'll run through what are all those new and exciting things that we have available in the software. As I mentioned, there's quite a bit of it, so we're going to only do part of it today. I'll be using some desktop demonstrations to make those things happen. And then I'll talk a little bit about some other new things that are coming along at Hydromantis. And then, as always, because this is a live webinar, we can actually show and answer questions from the GoToWebinar dashboard. So if you look through the options on your webinar dashboard, you'll find a question section. Feel free to type in any questions that you want. We'll just kind of let those accumulate as I'm going through the presentations today. And then at that point, at the end of the webinar, I'll hang around for 10 or 15 minutes and answer those questions as we go. Okay. So the thing you need to know is that users who have yearly subscriptions to GPSX or an active technical support contract will receive the update to the new version automatically. So you will receive an email from us, and it'll have 3 things. It'll have instructions about what you're supposed to do. It will have a file which you need to place into a specific folder on your computer, and a link to where you download the new version of the software. And that will update your license. That will give you the new version of the software, and you should be ready to go. If you do run into any problems going through that process, of course, please let us know. We can help you out. And if you are unsure if you qualify for the automatic upgrade of GPSX or not, then please just send us an email and we'll get you sorted out. Okay, so of course, what we want to do when we put out a new version of the software is to include all the new things that we've been developing since the last release, and we want to have improvements on both the software interface side so that it's easy to use and it can improve your efficiency and ease of doing modeling projects, and also to improve and expand the wastewater model content. So you'll find that we have new wastewater unit processes this time, some updates and new things that are in the biological models. And of course, there will also be new software features that you can use to generate new information and reports and so on. So at the same time, of course, we also correct some other known issues and background things that people have made us aware of and that we have solutions for. And then we do a lot of work in the background to kind of tweak our models and our solvers and so on to make sure that everything is running smoothly and robustly as well. So most of the new things I'm going to talk about today are part of the GPSX Standard and Pro licenses. So I think most of what we'll talk about today should be available to everyone. There are a few new things that we'll be showing you that are new libraries and a couple of new tools that are available only with the GPSX Pro Plus license. So if you're unsure which license that you have, you can always send us a support question and we can help you sort that out. Okay, so let's get on with the good stuff. What are the new things that are coming in GPSX? So in version 8, the first thing you need to know is that we actually have several new libraries. So the libraries that you're accustomed to working with are either our older legacy libraries that had the models ASM1 and ASM2D and so on. But actually, a majority of the people who use GPSX use Mantis 2 model and Mantis 2 Lab. That's our comprehensive model that is used for most projects: carbon, nitrogen, phosphorus, pH, inorganic precipitation, and all that good stuff. We also have a lot of clients who use our carbon footprint library as well. So those are the 2 that we had previously, and we have 3 new ones. We have a new model that is based around doing the modeling of all the regular activated sludge stuff in Mantis 2, plus also sulfur and selenium. We also have a new model for doing process water treatment. So different kinds of unit processes. I'll talk about a little bit later on, and also doing that to a very high quality, ultra pure level of water treatment. And then also an industrial version of GPSX. So this is for petrochemical, for refineries. It can be used for a number of different industries, but it is basically around the idea of having an industrial wastewater version of GPSX. We also have 13 new unit process objects that you'll find in your process table on the left-hand side of GPSX. We also have a number of new drawing board features, new data handling and data validation tools for getting all the information in and out. We have a number of new types of tables and outputs that will be helping you enhance the information that you get out of GPSX, make it easier for you to be able to get that into your reports and in front of your clients easily. We also have updated the wastewater content. We've changed and updated a number of our existing models. As we almost do every single time we release a new version of GPSX, we revisit our calibration of our models as that has evolved now over, I believe, about 9 or 10 years now. We've had Mantis 2 model, and we've evolved it over many versions to be able to improve that. And we also have new integration with the Python programming language. This is a really big thing that we worked quite a lot of effort on to be able to incorporate that. So we have this nice, fully integrated native Python connection between GPSX. And so we will be running, oh yes, plus more. There's a number of other small things that we'll touch on as we go through the next 3 webinars and hopefully hit on all of that important stuff. So what I'm going to do today is focus on a number of the software features and some of the new individual unit processes. So we've decided we'll pick that up again next webinar, and then we're going to leave the Python integration actually to its own webinar. So 2 webinars from now in November, we'll have a special one just for the Python integration. Okay, so let's take a look at some of these new interface features and tools that we have. When you open up GPSX version 8, the first thing you'll notice is that the drawing board now looks a little different than it did before. In particular, we've worked quite a bit on making it clearer exactly how all of the unit processes are connected and making it a little easier to navigate complex layouts that have a lot of objects and a lot of lines on the drawing board. So we've gone with a little bit more sort of modern drawing style for drawing board technologies. There's rounded corners on the things. We've now got the ability to do different thicknesses, and we can also do different colors on each of the lines. So we've got it set up right now so that when you're dealing with something like mixed liquor, that will show up as a brown line, and when you're dealing with effluent or so on, something clearer, that's going to show up as a blue line. And another thing that we did too was we redesigned the way that the combiners and splitters show up on your drawing board. This actually helped a lot in order to be able to reduce the number of times that you have a corner in your line. And so this has actually helped quite a lot. Many of the layouts that you will load from your older versions and load them into version 8, you may need to rotate a few things around, but you'll find that it really helps a lot to simplify the look of the way that your drawing board has been put together. Another thing that we did was we changed the way that you zoom in and out on the drawing board, and we now have a sort of a bit more standard way, like scroll bars on the side, and we have a new zoom button up here that works a little differently than the one that we had before. You don't have to use that locator where you would draw a box anymore. This is a much more standard way of doing it. There's also using the mouse wheel to be able to move around as well. So I think you'll find all of that stuff very intuitive to use, and it's very helpful. So let's take a little quick look at that right now. So as I mentioned before, you can see now the nicer looking lines, and they sort of match and fit to the objects a little bit better. If you take a look at the splitters and combiners, they kind of look weird sitting in the unit process table here, but when you get them on the drawing board and you hook them together, you'll see how having those things pointed in different orientations has helped to simplify the look and feel of your layout itself. Okay, so the new zoom buttons up here, if I were to, for example, zoom out a bit, you can see I can do some scrolling around, a little bit more straightforward way of doing that. If you hit this zoom button up here, it's always going to zoom to this orientation, basically fill up most of the screen all the way. Many of the places that you know in GPSX, you have to connect and go and right-click on the connection point. We've actually reorganized the way that it detects doing that. You'll find that it's much easier now to select a connection point than it used to be. So we also have a new feature here too, which is something I've been trying to take advantage of a little bit, where we can now replace the drawing that we have for any particular object with an actual picture, if you like. So for example, for this sludge haulage truck, if I go to the labels, I can change the image from the vector drawing that we do to an image. So I went out and I got myself a truck here. That's an actual picture of a truck, and now I can put that on the drawing board as well. And so that will be part of your layout going forward. So it's actually been an interesting way to sort of represent different types of technology. As those of you who've used GPSX for a while know, sometimes you have to use combinations of objects to be able to represent something other than what they were originally designed for. And so now you can actually just put down a picture of the thing that you were actually talking about. We've also moved the plant-wide layout button here, the site properties button, from up here where it used to be. We were running out of real estate here with some new buttons that we've been putting in. And also, I think it was easy to sort of forget about it when it wasn't right on the drawing board. So this is the button that you press to get access to things like the plant-wide properties, the elevation above sea level, and most importantly, the liquid temperature. That's, of course, a really key thing that you're doing when you're calibrating a model anytime to make sure you have the correct temperature. And so now that's sitting there on the drawing board, and hopefully a little bit more easy to access and keep in the front of your mind. Okay, so I'm going to flip over to another layout here. So let's not save those changes. One of the features that we also put together too was a way that makes it easier for you to keep track of what changes that you have made in your layout as you've been going along. So normally you'll know that when you open up a GPSX menu, you'll see that any place that you've made a change away from the default GPSX value, like here we've changed the actual volume of this tank from the default of 1,000. That actually shows up in blue, and if you've changed it in a scenario, it shows up in green. But now what we've done is taken all of that information and put it in one menu. So for example, quite a few things have been changed in this clarifier here. And if I slide down here to this new summary of changes, this gives you a list of everything that's been changed in this particular object. So we can see here that there's a lot of changes been made. In particular, a lot of things have been set up around the idea of an MLSS controller here, so lots of stuff. But if you ever wanted to know what are the things that are different than the GPSX default in this particular object, you can find that easily. Here you'll note that we have these buttons along the left. That takes you to the actual menu. So where do I find the wastage pump flow in that clarifier? If I just click that, it'll take me exactly to the right page and right menu for that. So that's sort of a handy way to navigate around, get to the information that you want easily and quickly. So you'll note only the things that are changed from the defaults will show up here. So in this aeration basin, the only thing we changed was the volume and this recycle pump flow. We also have another brand new feature too that's called the find feature. This is a way to actually search for things within your layout. So first of all, for very complex layouts that have a lot of connection points, sometimes you'll be looking for a variable and you kind of forget which object it was associated with and so on. So you can now actually search for a particular label, so a particular stream label, a connection point. So this one, for example, was highlighted right here. You'll see in light blue that that's been highlighted. Or I can actually search for a particular parameter. So for example, if I wanted to look for, I want to set the efficiency of the removals in this microscreen, but I can't remember the details of it and what I'm looking for. So I will look here, and this gives me a list of all the parameters in this GPSX layout that have the word efficiency in it. When I'm finding the one that I want, I click on this button, it takes me right to that menu. So it's a nice handy way to be able to navigate to the things that you're looking for in an easy way. For those of you who do some GPSX customization and you use those cryptic variable names as part of your code, you can also search directly for cryptic variable names as well. Okay, one other thing that is another significant change that you'll probably notice right away is that we have also changed one of the output menus that you tend to use quite a bit. We've now created something called the concentrations menu. Previously, when you came to this point and you were looking for your output that you would put onto graphs and so on, you would see state variables and composite variables. We combined those two menus together because really they're all about the concentrations. And I think it was a little bit left over from the older days when the menus were laid out differently with different information. So we condensed it, made it a little bit more straightforward to use. And you'll see now that all of the things that were both state variables, you know, the ones that we're integrating and doing our mass balance on, and the composite variables, the ones that you're most likely to have a lot of data for, they've been now put together and organized in one menu. So you'll find all of your nitrogen information all together in one place. So it's mostly just about simplifying the menu layout that we have. So one of the things that we have to keep in mind as we keep improving and adding things to GPSX is our menus kind of get bigger and bigger, and we have to organize them in a little better way. Okay, so speaking of menus, I'm going to flip over to another layout now. And I wanted to highlight a couple of interesting things that our software developers have done with the way the menus work. So if you're familiar with our IFAST model and our MDBR model, you'll note the operational menu was, you know, sort of a very densely packed thing that had a lot of information. It still is to a certain degree. But we had many, many, many of these array vectors things down at the bottom that represented settings that are used across the length of this plug flow tank. And the IFAS object was an even the best example of this because we had settings for volumes, for airflow distribution, for things like the media fill fraction, recycle rates. There was a list of about 6 or 7 things that were here. So what we've done now is we've actually organized those into a table. So previously I would have had actually a button for each of these 5 things, but they're now listed together all in one table. They can be dragged onto sliders and everything just as before, but now it's a little easier to handle and organize that you can get access to it there. The internal recycle settings menu has also been simplified in the same way. So you can come in here and create a recycle from tank 6 to flow to tank 2. And these a little bit right here is actually new. We now allow for proportional recycles, proportional to a particular stream label. So that's a new feature there as well. And then you can see here other media settings and so on that we have, which otherwise would have made for a very long menu. Okay, so let's actually run this simulation here so I can show you a couple new output things as well. So I'm just going to solve this for steady state. And a lot of our things that we normally use in GPSX, the ways that we find it useful to display the voluminous amount of information that comes out of these models, is to put them in these tables here, this quick panels, as we call them. So for example, in this IFAS tank, we can see the summaries for the 4 reactors in series and the effluent, what's going on in this particular tank. And that's the same as it was before, but now we have another version of it for input. So if I click on these simulation parameters, now I can see a very similar summary of the input to the model. These are the values that you set across the menus down here. We put the same kind of philosophy here. Only the most important things that you need to see are here. So we can see reactor portion filled by media and the volumes of the individual reactors and so on. So just another little tool that you can use to just keep everything close at hand that you need to know. Okay, so the most important thing, or one of the things that we spent quite a lot of time on in this, was creating a new Microsoft Word report. And that is accessible from this report button at the top here. We actually have it available many different places, but I'm going to use the one at the top here because this is the one that summarizes all the information in the entire layout. So what I'm going to do is I'm going to generate this new Word report. It's going to contain all of the information that comes in the model. It only takes a couple seconds to generate it, and then it'll ask you if you want to see the results, which we will do right now. And what you'll see is that you get a docx file, and it's got a lot of information. We put pictures of your layout and your plant information at the front. And then most importantly, we start summarizing all of the information that's in this system, in this layout that you've created, into tables that are all nicely formatted and organized for you. So for each one of these objects that's in your layout, so if we look at this clarifier one, we list all of the parameters where you've changed something away from the default value. So we show the parameter itself, we show you the units, the default value that we currently have in GPSX, and then the value that you changed it to. And so that actually works really well to be able to, really put this all together very quickly for you. And it's formatted really quite nicely. You get all of the output as well. And you also get, if you've entered any notes along the way, all of that information is summarized and put at the end here as well for parameter notes or for things that you put in the objects or any other place. So this works really nicely now, and you get these really fantastic looking tables with all of your input and all of your output. We also have a new diagram now as well. So up here, where previously we had a number of buttons for our operating cost and our Sankey diagram and so on, that's all been put into one menu here, and we have this new one called the mass balance diagram. And this is very handy because what it does is it puts together a image of your layout, and then it puts together the information that is all of the flows in between the objects in your layout. So I actually want to just reduce the size of this just a little bit so that I can get it to fit onto the page here properly. So just hold on one moment while I do that. That's one of the customization options here, is to fit it to the size that you like. So you can see here that what this is indicating is that for flow, TSS, COD, total nitrogen, total phosphorus, we can get concentrations and we can get mass flows for each one of these connection points. So there's an auto arrange feature that places all these boxes into what we think would be the most appropriate place, but you can actually move them around or delete them. Say if I don't really need that one, I want to leave more room for this one. You can customize this and save it as part of your GPSX layout. The idea behind this is that we want people to be able to easily track the mass flow of all of the important components that are in their system as you move around that layout. And this is something that I know many of our clients were generating sort of on their own outside of GPSX using our results. So now you can automatically do that and then customize it with the click of a button. So let me go back to my slides. So the idea here is that we've created a legend that sort of shows you what each of the values that you see in each of the boxes in order to sort of save on some real estate and some space in that diagram. But you can customize all of these. And in fact, you can even customize what you want to show up in that list as well. Okay. So that's a number of the new interface features that I can cram into today's presentation. There's still another pile that we'll show you next month. But I'd like to get on and talk about some of the exciting new wastewater models and those libraries that I mentioned earlier. So just to clarify the way that this is going to work going forward, the GPSX standard license includes our regular Mantis 2 model that you've all been using regularly, and also the Mantis 3 model. This is actually something new. Previously, our greenhouse gas and carbon footprint model was an additional add-on. We have now rolled that in, and it is just a standard part of GPSX from now on going forward. So everybody will have access to both the regular Mantis model and the greenhouse gas model as well. So these, in addition to that, everybody will also have access to our new sulfur and selenium model too. So this one, as I mentioned before, is really taking the Mantis 2 model and expanding it, adding new components, adding selenium and adding sulfur. And you can see here we have lots of different forms of selenium here, selenate, selenite, elemental selenium, because we're going through this reduction process with the biomass. And same thing with the sulfur, many different forms of sulfur that you can find. And we also are supporting modeling all of that, all of those transformation processes by adding 7 new biomass types to be able to do that. So you'll see here that we have our selenium reducing biomass, and then we actually have several different types of sulfate reducing biomass that use different forms of substrates for COD, and also a sulfur oxidizing. So we're doing both sulfur oxidation and reduction, and we have all of these biomass type systems in this, biomass types in our model to be able to support that. So there's a lot going on there. Our Mantis IW is an industrial wastewater treatment. We used to have another model, and we published it actually quite a number of years ago, called Mantis IW, that was a much simpler version of what we've implemented now. So This new model actually takes the Mantis 2 structure and expands it for industrial wastewater components. So there are a large number of new components, but it still has all of the stuff that you would normally be used to seeing in the Mantis 2 model, like the gas transfer and precipitation and pH models and so on. And we've supplemented that with 10 different types of hydrocarbon groups. And each one of those is undergoing biodegradation as you would normally expect in these models that we have, the volatilization and actually sorption for each of those. And they all have their own individual sets of parameters that describe that. So in that way, it's actually somewhat taking from our information that we've learned over the years from our ToxChem package, being able to use that type of approach combined with the Mantis 2 modeling sophistication that we have in GPSX. So you can see here, here's some of the different types of substrates in our industrial wastewater treatment model, the industrial version of GPSX. So we have aliphatic compounds and organic solvents and aromatics and so on. We have included oil as well. We actually have a new object there for the oil-water separation in this library. And then we have 5 generic user-defined industrial compounds that you can actually specify what you want those to be and include them in the system. And lastly, our Mantis process water treatment model is, as I mentioned, for ultra-pure water treatment. And so we've been developing this now for a couple of years, using it in-house for our own projects, and it's now being released for GPSX. So this is for doing primarily chemical and physical treatment, although it does still have the biological treatment aspect in there if you want to use it as well. What we're seeing it being used for right now is process water treatment. So for manufacturing facilities want to model the treatment of the water that they're using in their processing facility. For water reuse, so treating effluent wastewater to a higher level so it can be used for other purposes, and for drinking water treatment as well. So as I mentioned, focuses on physical and chemical, and it has a number of different new unit processes and new state variables that are available in the model. You can see here that the components that we have are a little bit like some of the precipitates that we have in the wastewater version, but we have expanded that by quite a lot. And we have a large number of new unit process objects that are available for this library only. So you'll see here things like cooling towers and boilers, evaporators, many different kinds of ion exchange and neutralization, lime softening, and so on. So these are all things that are available for this specific library. So you can do things like drinking water treatment like this. Okay, so those are all new. Specifically, as I mentioned earlier, Mantis 2, Mantis 3, and the Mantis Sulfur 2S, we call it, sulfur and selenium libraries. Those are all available to everybody as part of the standard license. However, Mantis IW, the industrial one, and Mantis PW for the process water, those are actually add-on modules that will be purchased on top of your existing license. So I didn't have a lot of chance to go into detail today. So what we're planning on doing is later this year and early next year, we'll be taking webinars where we're going to look at those 3 different biological models, those 3 libraries, Mantis 2S, Mantis IW, and PW, in their own webinar where we can go into more industry-specific applications. So keep your eye out in the near future for those webinars. Okay, so there are now, as I mentioned, 13 new objects in GPSX. This is actually the biggest number of new objects that we've ever added to GPSX in one shot. So we have a number of things like a new influent object to represent rainfall. We have aerobic digester that's been updated and calibrated. A new pipe object to represent long distances and hydraulic lag, so to speak. And a customizable 2-outlet black box model. We have a new UV disinfection model, flat sheet MABR, aerobic granular sludge model, thermal hydrolysis and sludge incineration models. We also have reverse osmosis, passively aerated biofilm. That was a special project where we worked on a biofilm system that had these sheets with air passing over them and so on. Aerated struvite recovery and sludge drying. So I won't be able to go through all those today. I'm going to do 5 of these, and we'll pick up all the other ones in the next month's webinar. Okay, so let's talk about the one that probably we had the most requests for, which is the aerobic granular sludge process. So this is a 2-phase solid liquid model that combines the best of what we do with our biofilm models with the way that we operate our SBR models. So this allows you to model it in the way, like the Narita system, where you will fill and aerate and then have anoxic times, and then you decant and let it settle, and then you decant. So it needs a cyclical operation settings. As you'll see, it has a full biofilm model, but it's been modified in order to work for granular sludge as opposed to biofilm growing on a fixed surface area media. That's one of the aspects that was where we focused quite a lot on the development of this, is that granules grow differently than the way that biofilm grows on a piece of plastic that has a fixed surface area. So as the granule gets bigger, the surface area changes and so on. So that needed a bit more sophisticated model than the way that we would do it. So we actually allow for not, some of the other earlier models that we'd seen published were very much a fixed granular mass. This is now allowing us to grow new granules. So you can start from a startup position and model how that's going to go as we grow new granules and they get bigger and so on. Okay, so let's take a quick look at that. We have, as you may know, a sample layouts feature in GPSX that allows you to load up, I think we're getting up to about 80 layouts now. So if I go to unit process examples, you can find in here an aerobic granular sludge object. And so let me close that. And we can see here, I'm just going to open up the menu so you can take a quick look. We have our physical menu where you specify the reactor size and so on. And then you also have these types of menus here for setting the cycles, and it's very much the same way you would do this for the SBR. So if you're familiar with setting up an SBR, it's very much the same kind of way. And then many of these other things are very much like our biofilm models as well. So I just want to very quickly run a short dynamic simulation here so that you can see things. Like you can see here our granular mass moving along. That's pretty much being held constant. This is the volume of the reactor. We can see here there's periods where it's pumped down and then filled back up again as we were decanting off some of our flow and some of our treated liquid. And then we can take a look actually at the concentrations inside the reactor. So without going into a lot of detail, you'll see here, of course, that the DO goes up and down, and there's aerated periods and anoxic periods. And we can see in this graph here, green is the ammonia. So periods where the air is on, we're seeing some nitrification happening. All that ammonia is starting to be removed, and we're generating nitrate, which is the black line. And then that's undergoing some denitrification here during the anoxic periods. So as those things go back and forth, we can then use the various parameters to look at the capacity of what this particular sludge, granular sludge reactor would be able to treat. So it works very much the same way. It's just a little bit of an advance of, it's one of the more complex models in GPSX now, where we've combined SBRs with biofilm and then modified all that to work with granules. Okay, so let's go back to our slides again. I'll talk very briefly about our new flat sheet MABR bioreactor as well. So as you know, we have a hollow fiber MABR model that exists in GPSX. It's been out for a few years now. So we have also produced a flat sheet. So you can imagine it's a flat spiral round sheet that are inside these reactors here. And then we have a number of those in series. We worked with a vendor who makes this type of technology, and we're able to calibrate the model well to a full-scale operation. And again, you can find that by going to our sample layouts menu. Let's look at these unit processes. And if I go down here, we can find the flat sheet MABR. And I'll just very quickly run it at steady state here. You can see this particular unit, for the example that we've set up here, is being used to handle, take some of that load of BOD removal and nitrification up front here, and being able to do that by specifying things like the number of modules in series, the number of spirals that are found within each module, and then we calculate the total surface area from that. And then we apply actually very much the same type of biomass that we do in, or sorry, biofilm model that we do in our other biofilm models in GPSX. So you can look at a lot of the details around what's going on in this MABR unit. Okay, so I'm moving on again. One thing I'll mention is that our hope is to, in next year, after Christmas in 2020, we'll be spending a lot of time doing webinars on each of these individual new processes, especially the advanced ones, to be able to give you some more detail. But I wanted to touch on the most important aspects of them today. So we talk a little bit about the reverse osmosis unit. This was actually work that we started out in the process water library, but then have now brought it into GPSX as well. So you specify the physical configuration of these RO units, and then you can calibrate the removal efficiency. You can use the operational settings for things like feed pressure and so on. And then we can remove soluble components out of that waste stream. So I have another example of that, sample layouts, unit processes, and let's go to reverse osmosis. And so this would be typically used in a situation like this, where this is probably a plant that would be doing water reuse. So after an activated sludge process and then membrane filtration, there's applying some reverse osmosis technology here to be able to get a very high quality effluent and some brine that contained the concentrated soluble components that were removed. So if we just run this at steady state, and I'm going to hop over to the reverse osmosis unit here. And so in this case, we're calculating things like osmotic pressure and then an efficiency of removal of those soluble compounds based on either their type of charge, like the type of compound that you have, whether it's a monovalent ion or multivalent ion and so on, or you can actually specify it directly. You can actually specify for each one of the soluble state variables that we have in the stream what its removal efficiency is. All right, I'm just letting this thing come to steady state here, and what you'll see is as we go through and we compare the feed concentration versus the filtrate concentration, things like ammonia and nitrate and so on, and soluble phosphorus will be lower. So here's our ammonia, and the feed is 0.2, but coming out of the filtrate is 0.01. So you treat it down to a very low level of nitrogen in this particular effluent. And if we look in the brine, we can see these are the concentrated values that were taken away. All right. I'll very quickly mention our runoff model as well. This is actually something that was kind of buried away in one of our other influent objects, and it never got very much use. So we kind of reinvented it and brought it out and gave it its own new object. The idea behind it is you specify a rainfall event in some sort of inches or millimeters per hour, and the catchment area, and there's a few other model parameters. And what it does is when you give it a rainfall event, it will give you a time series of water flow coming into the plant. And the idea behind that is that we can then sort of mix that with the regular wastewater flow, and then be able to see sort of the typical behavior that you would get when you have a wet weather event that kind of dilutes the flow coming into the plant. So in this layout, we don't have the whole wastewater plant here. We really just have the influent part, the regular raw sewage coming in, and our stormwater. And what I'm going to do is I'm going to show you the flow rate here, and I'm going to run a long simulation because otherwise it's going to go by too fast. And I'm going to make a bunch of rain happen here, this rainfall depth. If I go along here, and we can see the flows coming into the plant, and if I just go up and down like that, make a rainfall event, you can see it takes a while for the watershed to collect and deliver that flow to the plant. Eventually it goes back to zero, but I can make a bunch of weather happen one after another. The idea behind this is that you could theoretically have something generating some weather for you, or you could read it in from a file, or use a random number generator, whatever you like, to be able to have some weather, and then the hydraulic delay of all that flow coming to the plant will be handled by the stormwater model. And you can also characterize this influent. Right now, we characterize it as essentially more or less clean water. Okay, and the last one for today is our aerobic digester. You probably, if you had ever run into an aerobic digester before in the work that you've been doing, you probably used just a regular completely mixed tank with diffused aeration. That was perfectly a great way to do it. That's the way we always did it before. However, we got an opportunity to work with a slightly new and updated alpha value for the diffused aeration that is actually a model. Normally we set alpha as a constant in our models, but here we were able to correlate it to the solids concentration. So, and that really works well. We had a couple of really good papers on that, where we were able to find nice correlations that showed how the alpha decreases with increasing solids content in that digester. So I won't run the simulation now since I'm running a little bit long, but I'll show you, for example, here where in the diffused aeration menu, we now have a correlation. You can either set it or you can correlate it to the solids concentration, and we'll calculate an alpha value for you. So during periods when you may have more solids in your digester, you might require more air to be able to do the job. All right, okay, so that's the end. I apologize for going a little bit long and also for a little late start there when I was talking away, not realizing I was muted. But what I'd like to do is just highlight that we have a lot of really great new features that are in the software. We've got we focused quite a bit on the data in and out this time. That new word report is actually, I think, a really fantastic new feature. On the input side, we have some new data validation tools that we'll talk about next time. And then, of course, we have all those new objects. Many of them, or almost all of them, have come from requests from our clients like yourselves. So if there's anything you ever want to see in GPSX and we don't have it, let us know. So more to come in the next webinar. I'd like to, before I depart, just mention that we will be at the WEFTEC conference in Chicago in a couple of weeks from now. We are presenting, we have a booth, we're taking place in some workshops. Taking part in some workshops, and so our booth is going to be in the South Hall, which is the one on the right in this diagram. Right about here, we're booth 2719. It's right near the area where all the food is, and so we would be very happy if you're at the conference for you to drop by and see us in the booth, and we can show you GPSX version 8 live. And we can answer any questions you'd like to know about the new aspects of the software. My colleague, Rajiv Goel, is actually giving 2 presentations at WEFTEC on Tuesday, one in the morning on a new and updated high purity oxygen model that we created for one of our clients and implemented that at a full-scale treatment plant and some of the experiences that we had there. And then in the afternoon at 4:30 p.m., he will be presenting about the new aerobic granular sludge model that I was just describing and running simulations for you earlier. So he'll have lots of detail in his talk about how that new model works. And I will be presenting on Wednesday at 8:30 in the morning about using machine learning and AI techniques for doing influent forecasting and how you can use that to input into GPSX and use that kind of information as a really good way to provide input for your model. So if you're able to make it out on Wednesday, bright and early in the morning at 8:30, I'd be happy if you could make it by my talk. And lastly, I would also encourage you, if you have a chance, to come and see us at the one of my favorite parts of WEFTEC, where they're using, you'll see all the teams will be using our SimiWorks OpTool simulator as part of the process control event, and that usually happens around 10:30 a.m. On the Monday morning, and you can find that actually in the other hall, the North Hall in booth 7027, and the competition happens really fast. It's all over in about 15 minutes. Okay, so I have 2 upcoming webinars to let you know about. On Thursday, October 17th, we're going to continue on with part 2 of this series of the new things that are found in GPSX. So we'll talk about some more interface features, some more updates, some more new objects, and so on. And then in November 14th, at 2 p.m. Eastern, we'll be talking specifically and only about the new Python integration in GPSX. So we're going to run through how it works, how you can control GPSX from Python, how you can interact with models while they're running to read data and set values in the model and so on. And so we're also very excited about that as well. If you have a particular thing you would like us to do a webinar on, please let us know by sending an email to support@hydromantis.com or webinars@hydromantis.com. Let us know if there's anything that you would like to learn more about with our software. And I would like to thank you all for coming today. So the plan right now, it will be that I'll take a look at a few questions that I see that we have in our questions box before we depart for the afternoon. Okay, so let's see. Okay, so we have a question about the MABR process model. Let's see, an upfront influent. Does it, actually, this question requires a long, detailed explanation, so I think I'll follow up the MABR question with a response back to you directly, Andre, by email. But generally, the answer to the question is in the MABR, and in fact, in all of our biofilm models, we actually incorporate all of the rate processes that would be part of the regular Mantis-2 model. So that does include absorption for COD into the biofilm itself and onto the biomass, and all that biomass growth for doing nitrification and denitrification and COD removal and anammox and everything else that's in there can potentially run in the MABR object as well. So another question, if I open a previous version of a model created that you created before and then open that in the new version, would all of those things be available in the new version? And the answer to that is yes. So what will happen is if you load an old layout, say you created a model in version 7 and you load it into version 8, you will get a message that will pop up that tells you that, okay, this is an older version and we've upgraded it. We make a list of anything that is something that you need to know about, like if a parameter has changed, or maybe you've saved a value of a parameter in the old model that parameter doesn't exist in the new model. We make a list of all those things so you can be aware of them and anything that you may need to check on. You'll have to then rebuild it, but then once that's done, it's all in version 8, and then you can go from there. And so you may find that your results are slightly different. That's what sort of comes with the recalibration of the model, but you should be ready to go. And if you have any questions when you update it, you can always send us an email for assistance. Okay. Can I upload pictures of the equipment to customize the library? You can do that on a layout by layout basis. And so it is actually an interesting concept to actually create your own library of different types of equipment with different pictures, something that we've been thinking about. But right now, once you've built the layout with our standard objects, then you can update your pictures into that. All right, so can the model do energy balance for biosolids thermal treatment? So the answer to that is that in our Mantis 3 carbon footprint library model, we actually do some energy balancing in that model, particularly around the digester, because we wanted to be able to capture all of the offsets for the scope 1, 2, and 3 emissions that come out of the carbon footprint analysis. So in that case, we need to know a little bit about how much energy was put into the digester versus how much energy was captured back. So there's a little bit of it done in Mantis 3 library around that model. Okay, my goodness, there's a large number of questions which I won't be able to get to today, but I'll answer a couple of more. Okay, is there availability of a program to identify the size of the tanks? So by that, I assume you mean that, can GPSX be used to tell me how big I should make my tanks to achieve a certain level of treatment? And so the answer to that is yes, you can use it by doing a sensitivity analysis or use one of our optimizer features to be able to do that. We also have another piece of software called CapNetworks that is actually more designed to be able to do that. You specify loading and an effluent quality, and we figure out what size of tanks that you would need to do that. Let's see here. Can the RO process choose different modules from different vendors? Not directly. We don't have a list of vendors in the software, so to speak, but the RO model, and in fact, many of the different types of technologies that are used in the models that we have in GPSX are reflected by different choices in the input parameters. So you would calibrate your model a little differently, or maybe have a different specific surface area or something, depending on what that vendor might be. Okay, I'll tell you what, we're getting on towards 3 p.m. here. I realize I've gone way over time. So what I'm going to do is, for those of you who have asked questions that I have not been able to answer, I'm going to wind things up now, but I'll follow up with an email to you directly. And reiterate once again, if you ever have any questions about GPSX, you can send emails to any of our standard email addresses, such as support@hydromantis.com or info@hydromantis.com if you need to know anything further. And actually, there's my email address if you have a specific question for me that you would like to know about. Okay, thank you once again. I apologize for a little bit of a late start there, but I was happy to be able to go through some of those details with you, and I look forward to seeing you at WEFTech if you are going to be there. Otherwise, we hope to see you again at the next webinar about 1 month from now. Okay, thank you very much.